Alright, here in this video I'm reviewing what you should be doing for your GPX assignment. So the first thing to do is to go to the NCBI. So the easiest way to do that is to go to Google and type NCBI, and what we want to do is we want to go to nucleotide. So nucleotide like this, and home NCBI with nucleotide in the middle. So here we go. This is, notice, nucleotide database, and what we want to put in is, the first thing we want to find is your GPX genes, whatever you have. Everybody had a human one. I'm going to type in GPX, and let's type in probably the hardest one to find, which is 8. But notice, hey, it's giving you Homo sapiens, that's humans, Mus musculus, that's mouse, so there is a GPX8. That doesn't necessarily mean this is the one that matches with this one. Make sure you're careful with that and find the one that is the most match. Just because it's mouse 8 doesn't mean that it's the one that aligns best with the human GPX8. So just as a Bos Taurus is a cow, and let's see, I don't see Gallus. Yeah, okay, so go ahead, I'm going to search for that, and I'll show you as we go along. Now here is GPX8. Now putative means they think it's correct. So keep in mind that punitive. There may not be anything better than that. There are papers to read. I'm not expecting you to do that at this point. There are proteins and ref-seq transcripts. I'm going to go ahead and go here and see if this is genomic. It's better to get genomic data. I'll show you more on how to find it exactly every time if it exists. But you may not be able to find genomic data. You may only be able to find RNA data. And if so, that's fine. So here we go. It's showing us at least where it's at on the chromosome. Let's see. Do we have genomic? Now I'll show you how to read these, but essentially this includes the exons and introns in this little graphic there. And genome data viewer, let's go here. Just looking myself, this is not what you need to do. Again, it's back to this. That's not what I want to do. Alright. So we absolutely have the right thing. You might want to notice the gene ID at this point. You might want to write that down. So if you were doing GPX8 4933869, that might come in useful. But what I want to do is I want to go here to download data sets. So I want the gene sequences or transcript sequences, or protein sequences. It wouldn't hurt to do all of them. You really only need the gene sequences and the transcript. You can use all of them at one point in this class, so you might as well download all of them. So I'm going to download these. Alright, and they come in as a zip file, and then I'm going to go and look at those. So here I have now you're going to be on Windows, but I'm going to look inside here and see what these look like. So data set, data, and FNA, FAA, FNA. Alright, so the protein is a fast A amino acid, so they kind of give you that way. Fast A nucleic acid, that's what these mean. You can change those to just fast A. So I'm going to actually open this. I want the gene, here's the RNA. So let's just quickly, I'm going to copy that. And I'm going to put that on my desktop here. Oh, it isn't going to let me. I'm going to have to actually extract it. Alright. Extract. Show files. Alright, so where did they put them? Yeah, here it is. Gene FNA. So I'm going to rename that though for myself because I would prefer to type that as FastA. Alright, and it's GPX 8. I probably ought to rename it as Gene GPX 8, and it is Homo sapiens. I abbreviate that. You could write human, whatever it is that you remember it as, but there. So that's the one I want. Now, so I'm going to open that real quick with the text editor, like you would use Notepad, and I'm going to look at it, and it says GPX, Homo sapiens, gene ID, what chromosome it's on. It doesn't tell you it's genomic, but it is. So good, we have the genomic DNA for GPX8. Now, you would do that for your 2 genes, and I would go ahead and download all of these, get the protein and the amino acid. Your system may be different when you extract it. You're probably going to get all 3 of these. I would rename these as something like I did so that you can be able to identify them as a file that you can use in Eugene. So here I'm going to go to go to the NCBI, find your genes in the nucleotide database. That's what we just did. Download them. Alright, and rename to whatever you like. Alright, so that's what we just did right there, those 3 steps. And let's see, where did I save this? I saved this to, it's just in downloads. I'm going to cut that and paste. Oops, nope. I'm going to save a copy of it to documents or something. For now, I'll just save it to desktop. Alright, so I have my gene. It is somewhere under here, right there, gene GPX8 Homo sapien FastA. So this is the first part. You should do this with all 4 of your sequences. You need to find your Homo sapiens. I'm going to go ahead and do one more. I'm going to do another organism. So I'm going to go back a little bit here, and I'm going to say, well, I did GPX8. I need to find something similar, but I don't want to download that organism. I want to search for it. So I want to go to BLAST. So I'm going to go all the way back to NCBI when I searched, and I'm going to do BLAST in. And I'm going to find BLAST in, and I'm going to go here, and nucleotide BLAST. This is BLAST in. Alright, now I'm going to put in the sequence for, I'm going to put in the sequence that we just downloaded. Alright, copy, and I'm going to put that into BLAST in. Alright, now I'm going to scroll down, and then I'm going to pick organism. So my organism is not human. We're downloading the human 1, 2, 3, 4, 5, 6, 7, 8, but we are not, we want to search against some other organism. So I'm going to pick one. I'm going to do chimp. I'm going to do pan troglodytes. That's the chimp. Alright, right there, pan troglodytes. See that? Okay, so I'm searching against chimp. Alright, now you could exclude them. That's not what we want. We want to search specifically for this one, so that's what I'm putting in. I'm going to leave this here where it says highly similar first. Hopefully they are very similar, but we will search and find the closest one to it. And I just go down here to BLAST, and we wait for a second. Hopefully not too long. looks like about 30 seconds. Okay, now what did I get? I got pan troglodytes GPX8 mRNA. That's what we would have expected. All right, let's see if we can get the entire sequence. Aha, it's let's see what we've got. Now let's look over here. E value of 0. This is close to 0. All of these are close to 0. This is a pan troglodytes bacterial clone. I'm going to look at this one. You can use the RNAs. All right, that would show you something and be close enough for this assignment. But I would actually like to get the genomic data. This might be genomic data. So I'm actually going to go here. I'm going to see what the actual sequence is without doing a comparison. If I click here, it's going to go down here and show me an alignment. I'm going to go here and see what this is. And it's a bacterial clone of chromosome 7. Is it the complete chromosome? If it's a complete chromosome, it's too big. I think it's a large segment of the chromosome. I don't think it's the whole chromosome, but that's not what I want. That's too big. All right, so this is not what we want. All right, so I'm going to go ahead and use the RNA. Now notice this, that there are two of these RNAs. One is a variant, so these are mutations between in chimp. So we have two. We have their putative one. Both of them are putative. They're not sure. That means predicted. This one is a little bit more similar. They both have 0 E value. Let's take a look. Let's see which one is the longest, and we'll use that one. Alright, the FASTA here. Okay, we see pretty much how big that one is. There's a way to find out the length, but I'm not going to bother here. Alright, and we're going to go to the second one. Oh, it's giving us the alignment on the second one. I see. Oh no, I clicked on the alignment. I want to go here. FASTA. About the same. They may very well be the same. It's probably okay for these that you could pick either one. So I'm going to go back. I'm just going to take the first one. I'm going to go here. Just looking at it real quick, this is showing you the places that it aligns with the human and where it doesn't. That's useful to you, by the way. So, let me go back again. Come on. Oh, too much. Alright, here we go. So what I want to do is I want to download this one. So I'm going to go over here to this, the Ascension. I'm going to go FASTA. And I'm going to go ahead and I'm going to do it. You could go down here and send to file, choose FASTA, and just download it. I'm going to do it a different way, just to do it a different way than downloading it. I'm going to cut and paste it. So I'm going to grab it and I'm going to copy, and I'm going to create it inside my text editor. Alright, so here's the old one. I'm going to paste this in, and I'm going to save this as, let's say chimp, or let's say, GPX 8. It's at least if it's the one you want. The one that matches may not be 8. Maybe something else. You have to keep track of that. Make sure you keep track of what it is that you downloaded that was similar to this one. So, in other words, it may be something completely different, something unexpected. Whatever comes in as that top value, or the top couple of values that's useful, which you will have to judge. that's the one that you should download. In other words, let me save this real quick. What I'm saying is, when you came here, hold on, and this one, in other words, whatever's up here, this is the one with the lowest e-value and the highest percentage identity. So technically the second one, it has a slightly higher percentage of identity, but this one has more query coverage. That doesn't matter. But this is the highest rated one, so this is the one I got. But either one of these two, they have 0 e-value, which means that their sequences, even though it may not be as large as the one we were searching against, their sequences were essentially the same. There are a few variations, but essentially these are the same. E-value is percentage identity, e-value, query coverage. Those are the 3 you should look at in deciding. And I chose this one. Alright, so this is how you would download your genes. This is just a review so that you see how to do this. You'll need to do, you're of course getting 4 sequences. You're getting 2 human and 2 from whatever your organism is. Here I did chimp, but you might have cow, you might have, I forget what we were doing, cow, pig, chimp, and rat and mouse. So make sure you go back and know the technical names for those. Mus musculus for mouse. The Norwegian rat has a strange name, I believe, but that's the one you want. If you see, I think it starts with an N because it's the Norwegian rat. But I'm not certain of that. But when you look for rat, you'll know. All right, and if you have problems with finding the right species, the name of your species, like boss something is cow, so that's BOS. So when you're looking, make sure you get the top one, and then so let's go back to our description here. What do we do? Download and rename to whatever you like. Search in BLAST against the organism, I'll just say the designated organism. Search using this sequence. The human sequence. Oops. The human sequences. You're going to do 2 of them, of course. We just did 1. So the human sequences in BLAST against the designated organism. And download the top result. For each. Alright, this is the first part of this assignment. You need to do this, of course, twice, one for each of your human GPX genes. Save that.